Before we start, let us first briefly introduce the language Ojibwe. The users of this language are mostly the Ojibwa people, a group of indigenous people in North America. The distribution is indicated by red areas, mostly in North America and some parts of Canada. Words relevant to this topic will be presented, and we know that this symbol represents a powder stump. Here are the words relevant to this topic in phonetic form, and words in quotes are corresponding English meaning. Note that the column-like symbols indicate a long vowel or consonant. For example, k, and the symbol means k. Question A asks us to find morphemes meaning I and U and all their L-morphs. Question B asks, are L-morphs meaning I in complementary distribution? And are L-morphs meaning U in complementary distribution? Question C asks, if we were to find one phonemic form to underline each group of L-morphs, what should it be? And question D asks us to state a rule that derives the phonetic forms of the L-morphs, and to make the rule as general as possible, which means to refer to a broad natural class in the environment of the rule. We can state the rule formally in words or partially in words with some formal abbreviations. Finally, question E asks, is the rule a morphophonemic rule? That is, does it most likely apply to specific morphemes only, but not in general? Include evidence in the data to support your answer. First, find morphemes meaning I and U. After observing, we see that the words in the right column have an extra prefix compared to those in the left column. The English meanings reveal that the pronoun in the left column means she, while pronouns in the right column mean I and you. Therefore, it is clear that the prefixes colored red mean I, and those in blue mean you. Step 2. Separate the colored words into two groups. We see that the morpheme meaning I has two L-morphs, neat and knee, while the morpheme meaning you also has two L-morphs, quiche and key. Step 3. Check their environments. We further split the words into 4 groups according to different prefixes. After observing, we find that neat and quiche are both immediately followed by vowels, while knee and key are followed by consonants. And so the two sets are in complementary distribution. Step 4. Determine which is the default and state a rule. From our previous conclusion, we know that neat and quiche are followed by vowels, and knee and key are followed by consonants. If we assume knee and key are the default, then the rule will be like this. But since we don't have sufficient data, it remains unknown why it is t that was added to knee instead of sh, and why it is sh that was added to key instead of t. However, if neat and quiche are the default, the rule will be like this. When neat or quiche are followed by another consonant, we drop the last consonant from neat and quiche, leaving knee and key. This rule can be simplified as follows. The last consonant of the morpheme is dropped when it's immediately followed by another consonant. Step 5. We check the applicability of the rule. From the last step, we got this rule. And so, we search the data for words with the same environment, namely, a consonant before another consonant, to check if the rule is also applicable to other expressions in the provided data. We find this word, which we can see has k double consonant cluster. If the rule is applied, then the first k should be deleted and the word becomes this. However, it is not the case, and this language does indeed have long or doubled consonants. Additional examples can be found from the data. And so we reach the conclusion that the rule is morphophonemic. That is, the rule can only be applied specifically to certain morphemes like neat and quiche. We note here that a morphophonemic rule has the form of a phonological rule, but is restricted to a particular morphological environment. Here we briefly explain what is a morphophonemic rule. Take the prefix in from the English language, for example. In has the two L-morphs, ill and ear, which depends on the initial form of the word that follows. The relationship between the two L-morphs can be explained by the two rules. If n is followed by o, then n assimilates to o. But if n is followed by then n assimilates to However, these two rules are not phonological rules in English, but morphophonemic rules, because they only apply to the prefix in. If the rules were actually phonological, then the segments on and non, as occur in the following words, will also exhibit this regular pattern. But we can clearly see that these two prefixes do not change even if the words they follow start with or o. This once again proves that the rules are indeed morphophonemic. The following are answers from the publisher, which can be used as a reference.